Hello guys, welcome to Code with BK. So in this video, we solve the problem to extract ith bit from an int value. So in the first half, I'm going to explain you the steps, the process to solve this problem, and in the next half, we are going to look at the codes. So if you're someone who's just looking for codes, the link to the codes are provided in the description of this video. And to each link, there is a text explanation as well. So if you're someone who wants to read and understand, you can take a look at that as well.
Please do not forget to subscribe to this channel and click on the bell icon to receive all the latest updates.
So what do I mean by extracting ith bit from an integer n? Okay, suppose if I have an integer n value as 27. So this is basically a base 10 value, which is a decimal value. The corresponding binary representation of this value is going to be 11011. Integers in computer science, okay, in programming languages are stored as 32-bit value, okay, and these are the 5 bits. So you add remaining zeros to the left to make it a 32-bit value. Okay, so if I have 11011, okay, I add 0 to the left. Okay, these are 5 bits, so these are 27 zeros. Okay, and these are in all 32 bits. So you can add as many as zeros to the left. The value of this binary number does not change. Then there is something called the bit number. Okay, so this is bit number 0, bit number 1, bit number 2. Okay, the bit number is provided from the right end and goes towards the left. Bit number 3, bit number 4, bit number 5 is 0, and so bit number 31 is 0. So for 32 bits, you have bit number from 0 to 31. In certain references, bit number starts from 1, but in most cases you will find bit number starts from 0 only. So if I say I want to get the ith bit from this integer, it means I want to get a bit at any of these positions. So 0th bit in this case is going to be 1. First bit in this case is going to be 1. Second bit in this case is going to be 0. Third bit in this case is going to be 1. Fourth bit in this case is going to be 1. And 5th to 31st bits are all zeros. And given a value of I, okay, which can be between 0 to 31, and given a value of n, which is this, the bit representation of which we are looking at, give me the ith bit in n. This is our problem. So how do we solve this? So let me write this separately. Bit number 0, 2, 3. These are 27 zeros. Okay, and these are the remaining 5 bits. So now if I want to say extract the ith value and I is 1, so I want to get the bit at I equal to 1, bit position 1, which is 1. So what I do is I perform bitwise AND with a value which has all zeros except 1 at position I. If I call this, say, x, so I find n ampersand x. Okay, bitwise AND. So when you do bitwise AND, everything is going to be 0, okay, at all positions except the one at I, okay, because 1 into 0 is 0, 0 into 0 is 0, okay. So in this case, 1 into 1 is going to be 1 and this is going to be 0. So the value you get here, okay, if this has at least 1, okay, it means the ith bit was 1. If this value has all zeros, it means ith bit was 0. In this case, there is a 1 here, it means this ith bit was 1. How do we check if there is at least 1 here? This value, okay, and ampersand x, okay, is going to be greater than 0 if any bit is 1. And ampersand x is going to be equal to 0 if all bits are 0. So if my final value has all bits equal to 0, it means it is the integer 0, okay, that implies the ith bit was 0. If the final value I get is non-zero, that is, it is greater than 0, that means the ith bit was 1. So the task is to get this value, okay, create this value. So we already have the value of n. We have to construct this value of x. We can find n ampersand x. Ampersand is bitwise AND. This operator is provided in programming languages. Then we can check these two conditions, okay, to check if the ith bit is 1 or 0. So our task is to now construct this value x. So how do we construct this value x? So I start with x equal to 1. So x equal to 1 in binary form is going to be all zeros except the last one, which is 1. So these 31 bits are zeros, 31 zeros, and the last bit, that is bit number 0, is 1. We have to extract the ith bit. So 1 has to go to the ith bit number. So we do x is equal to x left shift I. That is, we left shift all the bits by I places, and this operator is again provided in programming languages. So all the bits move I places left. So in this case I is 1. So this 1 moves 1 place left. So everything to the right of this is going to be 0. Okay, since you shifted 1 place, you add 1 0. Okay, so these are 30 zeros, and these are the 2 bits, and these are 32 bits. So you start at x equal to 1, then you set x is x left shift I places. You get this value of x. So let me write a pseudocode that takes the value of n and I. It returns 1 if the ith bit is 1. It returns 0 if ith bit is 0. So I say function get ith bit, takes the value of n and the ith bit to find. First task is to set x to 1, then move x left shift by I places, then you ampersand and then x. You say y is n ampersand x. If y is greater than 0, okay, your ith bit was 1. So if y greater than 0, your ith bit was 1, so you return 1. Else, okay, this is the case when y was 0, you return 0. So suppose if I was 2, so I'll take x equal to 1 again and x left shift 2 now. So 1 comes here, and okay, these are 29 zeros, and these are the remaining 3 bits. So x is now 29 zeros, 100. So x is now 29 zeros and 100 at last, and 1 is at index I equal to because we are finding the ith bit. Okay, when you ampersand this, 1 into 0 is now 0, 1 into 0 is now 0, 0 into 1 is 0, 1 into 0 is 0, 1 into 0 is 0. So you get all bit 0, which is basically the integer value 0. So in this case, you return the else, okay, so you return 0. So ith bit for I equal to is going to be 0. So let's implement this and check this out.
So this is the implementation of the solution we discussed. So I've written a function get ith bit that takes integer I and integer n and returns the ith bit in n. Return type is int, either 0 or 1. Okay, starting with x equal to 1, left shifting by I places, finding y which is bitwise AND of x and n, and then returning 1 and 0 based upon that y is equal to greater than 0 or equal to 0. So let us run this for 27. Java C Java. Okay, 11011. Let us run it for say 15. Java C 1110, and let us run it for 10. It should be 1010. Sorry, 01 and 01. So I hope this tutorial was helpful. So please do like this video and subscribe to my channel. And please let me know in the comments if there is anything not clear to you in this video, if there is a concept you want me to discuss, or if there is a question you want me to solve. Thank you.